In this question, you have been asked to identify the effect which is responsible for the stability of a carbocation which contains a methyl group. Before that, we have to know what is a carbocation. Carbocation contains three substituent groups along with one positive charge on the carbon atom. They are electron deficient species or electrophiles. They will always have a tendency to attack a nucleophile to attain the stability. Now let's come to the options given here. The first one is minus I effect. This minus I effect is electron withdrawing effect. When an electron withdrawing group is attacking to the carbocation, they will take the electron density. So it will not stabilize as the carbocation. Actually, the carbocation needs a group which is electron donating. So methyl group is a plus I group or electron donating group. So minus I group will not stabilize as the carbocation. Only a plus I group can stabilize as the carbocation. So this option is the wrong one. And the second one is electromeric effect. This is also the wrong answer. The third one is given as hyperconjugation. Hyperconjugation is the stabilizing interaction in molecules where electron density from a sigma bond interact with an adjacent empty or partially filled p orbital or pi bond. This delocalization of electrons helps to stabilize the carbocations and alkenes. We can draw the diagram as given here. Due to the hyperconjugation, the carbocation, which is a tertiary one, will be highly stable. So the correct answer is hyperconjugation. And the last one is given as mesomeric effect. This is not possible in this carbocation which contains the methyl group. So the correct answer is option C.